Okay, go ahead. It's all yours.
Yeah. Pranjal, you can start.
Yeah.
Just 1 second, okay?
All right. So the title of our project is A Different Look at Sharing and Backup Systems. You can hear me, right?
Yeah, I can hear you. Great.
Okay. So the title of our project is A Different Look at Sharing and Backup Systems. Okay. So talking about the backup. Brijesh, next slide.
Yeah.
All right. So what is backup? Backup is the process of creating a copy of the data on your system that you use for recovery in case your original data is lost or corrupted. So you can back up files, folders, all of your important information and secure that for a later use so that even if there are some failures, you can still keep your data intact. So you can also use backup to recover copies of older files if you have deleted them from your system. So like there are still some people who don't know how like the backup works and like what backup is actually. Since we all are in the computer science field, we know that what is backup, how to do backup, where do these files get stored, what's the process. But still there are some people who struggle with all these information and end up losing their data. But nowadays the devices back up all data automatically. But what if you don't require all the data? What if you require selected files? Which is next slide. So our project is based on that problem itself. In all the major OS, you must back up all files or some essentials. So as a part of ethical OS, the system we propose would allow the user to manually back up selected files. So in the system we are proposing, you can back up selected files and select what files you need to your backup system. We propose a backup and file sharing system for UC Davis. We will place 3 node clusters and replicas at different locations. The first one at Memorial Union, one at San Francisco, and the last one at Sacramento. So the students who want to back up their data would have to go to the nearest location. They must manually upload the data to take the backup or share the files. The system has the flexibility to select all or part of the data. So you can manually select the files and upload it to the cloud, and it will help you to share those files and back up those files at a very secure location. It provides you the flexibility that you need. Like you can back up the selected files. So once you're done uploading the data, you have the option to share the data as well. But the precondition is that the users would have to connect with the campus Wi-Fi or to read the data. Next slide. All right. So how does the working of our system work? So the user, if you look at the flow diagram on the left of the screen, the user goes to the nearest location and connects to the EduRoam, the campus Wi-Fi, and user uploads the files they want to back up or share into our system. The next thing is that the user gets the option to backup files or share files. So either if the user selects the option of backing up the files, they can back up those selected files and share it, store it for the future use into the cloud. But if you want to share the files, you just need to select those files and you can just pass those files to the other user or like whomsoever you want to share them with. So yeah. Next slide. So what are the advantages and disadvantages of our system? So let's talk about the advantages first. The users get to back up their own data or part of it. Like this is what we are stressing on that system, that you can, you can back up selected files. You don't have to back up all the files. So data is easily shareable and multiple people can work on it, since the location of our clusters are like very genuine. You can go to the Memorial Union or Sacramento or San Francisco. So a lot of people can access it and you can share it with majority of people. So we can implement our own data reliability or security compliances rather than renting third party. cloud computing vendors. So it's like it increases the security of our system as well. You wouldn't have to face the errors that you normally face while backing up your files. So, and also there are a large number of data, GBs and TBs, that can be easily backed up into the system and easily shared without connecting to one network. You can easily share them like whatever the size is, because our system gives the user that flexibility. But the system also has a little bit of disadvantages. First, the main disadvantage is that the user has to manually go to the location and upload the files. So that is one thing, like one work that has been increased for the user. But also the cost of our system, it will be like in the long run it will be cheap, but like renting and implementing this system will require a very large cost. Yeah, that's all of it. That's all, both the disadvantages. Moving on, next slide. Okay, Brijesh,
Yeah.
implementation.
Yeah, for the implementation, we have done a small demo. We can see extension of assignment to where the user what data you want to back up. So the my data 1 or my data 2 or all of the data. So when we select all of the data in the second picture, at the last you can see that calling NFS term. We can see committed data. Both of the data are. So just now we have assumed only one chunk is there and both the data is pushed onto the same chunk. But if we have multiple chunks, then if we select all of the data, then it will be pushed to multiple chunks. And if we select only second option, then it will only go my data 2. So we can select only the data that we want to back up and not all the data. Result and analysis. So backup and sharing systems which are compliant to EthicOS, and our system inherently uses Google file system, and it keeps 3 replicas, one in UC Davis campus, other in Sacramento campus, and other in SF campus. So data doesn't get lost and is available all the time. And we can the system backs up the data only which is important to you. I can now show the demo, small demo that we have implemented it as a part of it. So this is let me run first all the master. This is mini GFS primary. This is secondary A and secondary B. So now if the client wants to back up the data, when the client runs, what data do you want to back up? So you can select 1, 2, or 3. Let's say if we select 1, then obtain chunk URL is, so first of all, obtain chunk URL is obtained. So all the 3 replicas are obtained by the client. And then first of all, the chunks are empty if you see before committing the data. And then after committing the data, push chunk to replicas, my data 1 is being written on the committed data file. So yeah, this was our demo.
Okay. Thank you, Brijesh and Prabhat. I have some question for both of you.
Yeah.
My first question is that how do you? So now you have a 3 copy. One is in Sacramento, one in San Francisco, one in UC Davis. What do you think that we can actually have a system which essentially around the world, instead of have 3, we have maybe 300,000 of such server. Of course, you still maybe have a 3 copy, 3 replica, or 4 replica. But we actually going to be able to access to because you mentioned about edge ROM. So
Yeah.
Edgerone is supported by all the university, right?
Yeah.
So as long as the university, they actually want to participate, they can actually offer a hard disk. Well, what do you see about that particular pass?
I mean, I didn't get the last part. Can you repeat? Like EduRoam.
The thing is that
EduRoam
right
can
now
then-
you're planning to do 3.
Yeah.
Is there any reason that you cannot make a 300,000?
Yeah, we can actually make 300,000, but the only reason, the problem I see is whenever we read or write the data, we have to write the data in all the 300,000 copies. So
No. I'm not writing 300,000 copy. I'm talking about still like a GFS. We have a master index server.
Yeah.
I still write to 4 or 3, but
Yeah.
it's not restricted to Sacramento, San Francisco, and UC Davis. I might have a 1 copy in UC Davis, 1 copy in China, and 1 copy in Australia, for example.
Yeah, that can be also be possible if the data compliant is maintained and if it is met. For example, if the university if the university accepts that we want our data to be held in another location, in another university or another country.
Okay,
then,
but the challenge to me is that where is the index server? Where is the master? If I have a 300,000 server, do I still have a 1 master, or I need multiple master?
I think it will be master per university. So one university will have at least 1 master. It will keep the data for its own university, I suppose. At least
I suppose that maybe you need to place like master in every like nearest, like for example, if you are locating that GFS in say Austin, so like in Texas you can just place 1 master in Austin itself, and yeah, I think there'll be a master in each and every state, I guess, if you are implementing that system in like whole United States.
I'm actually thinking a little bit differently. So the master index server in GFS, I basically need to tell the master that what file I want to access, what directory I want to access, and then they are basically gave me the chunk location. Then I go chunk to grab it out, right?
Yeah.
But here we're talking about backup for personal data, for my data.
Okay.
And therefore, I'm actually thinking I will be acting like a master. So essentially, I will keep tracking which 3 copy, where they are, just based on me. But I still need a master index server for the following. Now I call it master, but not index, because I want to know, oh, there is a chunk server I can use in Austin. There is a chunk server I can use in China, or I can use it in Singapore. So essentially, I think I like the idea of either every university or every state has a master server. And the master server, they know each other. They know each other. But to me, the master server just know the location about those hard disks. It's like a storage network, but they don't know what file put it. In fact, if I'm going to put it in Austin, I'm going to actually encrypt it and then put it in Austin.
So maybe like each university can keep 1 replica and a master copy. So if they have 1 replica at their own location, maybe the sharing would be easier. So they can easily write on 1 replica.
Right.
And if they have the master copy itself there. and then the other 2 replicas can be anywhere else.
Right. And also in that case, it will be consistent with edge roam, because you
Yeah,
go to the
yeah.
university, you can get the edge roam, and then you can
Edge roam.
access to that. Okay.
Yeah.
All right. So it's actually possible to make it. I mean, I like the idea because if you use the commercial storage backup solution,
Yeah,
it's quite expensive. Not only
Yeah.
expensive, but they actually charge by the size of
yeah.
the hard disk you try to back up. And typically it's not.
If you want to use for personal reasons, then it's very expensive. We
Yeah,
are
exactly.
Yeah, no, even for
if you're a
like
company or enterprise, then it might be a little bit cheap because
yeah,
we have a
for
lot of-
enterprise it's cheaper, but even for our
Yeah.
university, we try to back up the research data.
Yeah,
And essentially a lot of research data just cannot be backed up because they're too big
yeah,
for any kind of commercial. I mean, the commercial backup solution probably easily costs $1 million a year to
Yeah.
just help you to use that. I mean, that's actually even that the disk space is not big. But I think is if every university contribute a good amount of hard disk,
Yeah.
and we're education network, we're connected with high speed, and we should be able to have some good disk. So okay, so here is my question for you now. I think it makes sense, and the following question, I don't think you have considered that, but I'm going to ask you anyway.
Yeah.
So we have 3 copies. 1 copy in San Francisco, 1 copy in Sacramento, 1 copy at UC Davis. But we like to move some of the copy to another location. For example, I realized there's a new storage available in Los Angeles, and I want to move it there.
Yeah.
So essentially, when we talk about data movement, I want to make a more replica and things like that.
Yeah.
So how will you decide when the data is actually ready to move? So let me be more specific. Assuming I'm visiting UCLA, assuming I'm
Yeah.
visiting UCLA. So you can see that I was at UC Davis. Now I'm at UCLA. Now all 3 servers are in Northern California. And
so
at
like
that time,
you are assuming that the Sacramento replica at Sacramento, we have to move that into LA?
either Sacramento or UC Davis or San Francisco, right? Because otherwise I'm using UCLA edu ROM, and I'm just keep accessing in North Carolina. Even worse, if I'm in Texas, I'm in Austin, then all 3 copy in Northern California, and anything I want to do, including backup or retrieve, is going to be across a distance. And at that time, it might make sense to actually be able to move one of the replica to at least to Austin. So that make my sharing easier. It's still, if you use Google, you still need to update all 3. But the thing is that at least the sharing is reading part is easier. So what do you think about that decision? How do you actually decide when is the time for you to make a replica? Well, make a replica locally. I guess that's my question.
So we have to see how many of the users outside Davis are accessing into the EduROM in Davis. For example, what percentage of users are accessing that? For example, if there are high number of requests coming from outside, what the people are accessing it. For example, if you go to Texas and then you want to access it, but it might be just that the people in Davis are accessing more, and it makes sense more to keep the replicas over here rather than that. but as the number of requests increases from Texas or any other state or from whatever area it is coming, then we can keep a replica over there. That might be one of the case, I think.
Okay, okay, that's certainly okay. I mean, there's two possibility I see. One possibility, you're looking at the usage pattern, right?
Yeah,
And decide
yeah.
when it's moving. But the other way to look at example is it's like a caching. It's like a caching. I'm actually in. If you think about that, I'm in UT Austin.
Yeah.
And I decide to share my my data with the new colleagues I have in Austin.
Yeah.
So guess what? Initially, all of them are going to actually get it back through EDO-ROM to UC Davis. So my assumption is the first person who tried to retrieve that file from UC Davis, he is going to actually cache a copy at Austin, and such that you temporarily might have 4 replica. And the person, the owner of the person actually knows about that. And so he need to, I mean, the problem is that every time he make an update, he need to write back all 4 chunks, right? And but the thing is that if it's just one person access, yeah, you're wasted that network bandwidth. But if there are more people access, you start to win. So it's so this is pretty much like a content distribution network, essentially. So we're working on content distribution network, but we're looking at backup.
That makes sense. Yeah, crashing the file also.
Right. Yeah. Okay. That's interesting.
And another advantage is that once we have our own data, then maybe we can keep own servers also, so that we don't have to hire AWS, or maybe like we can have our own GPU servers and all, and then we can execute locally any file system that we want to execute. Like we already have the data. If you want to execute the data, then if we execute it locally rather than in cloud systems, it's much more easy.
So the earlier question about 300,000 copy, 300,000 server. I mean, I was thinking is that I can either go for per university. Per university means that every university decide to set up a hard disk or storage server to responsible for the university as one copy. But the other one, I can go for peer-to-peer. Means that I'm actually going to share my part of my hard disk in my home computer to do that. But of course, that means that the home computer is not going to be as reliable. So it means that 3 copy might not be enough. If you want to use everybody to do that using a peer-to-peer, you probably need 30 copy. Just a rough guess. You probably need 30 copy to do that. So that's but the good thing about 30 copy is that you don't need like a sysadmin. Is because everybody is providing whatever he has using the peer-to-peer. It's almost like a BitTorrent kind of scenario. Okay, all right. So I mean, I hope that one day we will have some backup solution like what you suggest, which can really reduce the cost for us to do the backup, to do the selective backup as you suggested. Either it's a peer-to-peer or it's an education base. I hope that will happen sometime. Okay. All right. Thank you very much, Prijesh, and also Pranjal.
Thank you.
I'm going to move to the next group. Oh, okay. Very quickly ask you. Projection, Pangel, have you done your homework 2, homework 3 demo?
Yeah. Yes. Yeah.
You did that, right?
Not the demo.
No. Yeah. So homework 2 demo we showed you on, I think, Tuesday or Thursday office hours. Homework
Office
3
hours.
we are
Yeah.
Okay.
Homework 3 is left.
left out.
Okay, I got it. Okay, no problem. I recorded here as well. Okay, so let's move to next group. Next group, are you ready?
Yes, we are ready.
Yeah, we all ready?
Okay. Yeah, you can just take the screen.
Okay. Okay, can you see my screen?
Yes, I can. Thank you.
Okay, cool. So, so our project is about a COVID exposure tracker for UC Davis, and to prevent the spread of the coronavirus, we designed this exposure tracker system which can be deployed in UC Davis campus. It can record the active time and location of different users, and when someone report that she or he tested positive for COVID, the system will inform the people who are likely to contact with this person. At first, this is how we decided. Clients send their active time in certain location to server, and server stores them. When clients test positive for COVID-19, they report to server. Server will search in its database to see who have overlapped active time and location with this client and notify them. But we have a problem here. How can we notify the clients? So we got a center server here. It would connect with clients when they enter campus, and client will request to it every certain time, like sending a heartbeat packet to check if they are safe. The center server will return false if it could not find the overlapping time and location. Otherwise, it returns true. And here is each component's responsibility. For the client, they will connect with center server when they enter campus, and connect with location registration server when they enter some specific location. And they should report to center server when they test positive for COVID. For the center server, it stores all the data. So when it get a COVID report, it can find the overlapping time and location of the person and inform others. And for the location registration server, it records client's active time in its location and send it to the center server. Here is how the system works. First, when clients enter the campus, they connect with to the campus network, which means they build a connection with center server. This connection is used by the center server to inform them when they were in a location where a potential exposure presented. And then when clients arrive certain location, they will connect with the location registration server. They send heartbeat packets to a server every 1 minute. When they leave, they won't send the heartbeat anymore, so the location registration server can record the enter time and leave time, then send them to the center server. Center server will store the data, including the location, user's ID, enter time, and leave time. When a client tests positive for COVID-19, they report it to center server. Center server will search its database to see where this user has been and find out other clients who are in that place when the positive client was there. And it further informs other clients. And to understand the system better, we have a demo. Here we have two locations in campus. camper and academic search. We can see ABC are in the academic search, and after a certain time, A left and reported that he tested positive, and the center server will inform B and C since they have the overlapping time and location of A. So this is basically how this system works. We also have a demo. How Nan can share the screen and to see.
Yeah, please let me share my screen. So.
By the way, I like your dog.
And thank you.
He's walking behind your back. It's very
Oh,
cute. I
really?
think he jumped on your bed or something like that.
Yes, he's sleeping on the bed now.
Yeah, okay, cute.
Okay, so let me show our demo here. So can you see my screen? We have
Yes,
different
yes.
servers and clients. Now in the most lowest panel, we have our central server. So we start our central server here. And in the middle panel, we have two location registry server, which one, the first one is for academic search, and the second one is for camper. So we start two locations registration server. And at the highest panel, we have 5 clients. 3 are in the location of academic search, and 2 are in the camper. So we start client D and client E who are in the camper. And at this time, they are keeping connection between the client and the location registration server. And they send heartbeats to the central server. Now we can see in the central server, we maintain the database that at what time who has been what place. And now we open the client B and client C in the academic search. At this time, all of them have received message which said stay healthy because there is no contact reported. So now I started client A. At the very beginning, it also received messages that stay healthy because no contact has been reported. But at this time, I guess, at this time, client A have reported by himself that he has been contacted, and the other clients in the same location, which is academic search, will receive notifications that say take care because the system knows they have been contacted by the positive of COVID. And at this time, we can take a look at the central server. It has maintains a list of contacted clients. So, and we can still see in the database who has been which place at what time. So yes, that's it. Thank you.
Okay. Okay. All right. I have. Thank you very much. And yeah, I have a essentially one important question I would like to ask all 4 of you. Can we reduce the role of the central server? It looks like the central server become a very important piece, is collecting all the information.
Yeah.
Which let me give an example why I'm thinking, what do I mean by, I guess in some sense we need to have a central server, but on the other hand, we can maybe reduce its role in terms of.
Yes, that's right.
Yeah. So
that's right. I think we can reduce its role by, at this implementation, every time a location registration server have received a registration from client, it will send a packet to the central server. But this is not the case in the real life. In real life, we can actually, we packet data from location registration server every 1 hour. It means the location server will only send 1 packet to the central server in 1 hour. So like we have 2 location server, it will only send the 2 package to the central server in 1 hour. Even we got like hundreds of buildings in the campus, well, in 1 hour, the central server will only have like 100 access.
Yeah, I have some. Okay, thank you very much. But I want to actually say I offer. I'm not saying better, but maybe an alternative design.
Oh, yeah.
Today, an environment like UC Davis, because we all need to get COVID tested every 2 weeks. So when we got tested, the university will know, okay, if you got tested positive or negative. Actually, there's another part of the thing which is interesting, is using the negative information. But let's look at positive information first. So when I got tested positive, I need to submit my footprint about where I have been to the university. So essentially, you can think about the university, they do not track my location until the point I actually confirm test negative. So essentially, each of one of us is actually keep tracking our own location. But that's not enough, because we want to inform those who overlap with me. So if each of us keep to ourselves, the reason you have a central server is that the central server will be able to keep tracking who have overlap with the positive. So we can actually get to them very quickly.
Yeah.
But the other possible way is that if we install one Raspberry Pi in every single building, and those Raspberry Pi is not connected to the internet. So we're talking about location privacy here. So you think about, there's a Raspberry Pi in the classroom that's actually has a record about all the people all the time have visited this particular room. But that information is not being centralized. So that information is sitting there, is disconnect from the internet. So here's what happened, is that if I got test positive, and the university actually take a look at my record, realize I spent time in this room during these hours. And therefore, at this time, the university need to find a way to access that Raspberry Pi. There's multiple ways we can do that, but assuming they have a way to access to that Raspberry Pi very quickly, and they can actually directly pull it out. So essentially, when you submit the test data, you actually already also submit your locality, and the system will automatically try to find out who are actually there. And then from that data, they will be able to immediately try to look for the other possible cases as well. Okay, here is another issue which will be interesting for you to consider, is just talk about the negative information. So what do I mean by negative information? So today we're looking at people who get tested. They are positive to COVID, so we need to worry about who are more vulnerable. But the other thing which is interesting is that if you got test negative, then essentially it's likely the people live around you, or your dormitory, or your classmate, they're probably, especially you live share a dormitory, share a room with a few close friends, then if you actually get test negative, which means that they also has a less vulnerability. And that information could be useful as well.
Yeah, that's a good point. Yeah. So
Okay.
we can span our our range of negative people with like only a branch of tests.
Right. Yeah, that's right. Yeah. Okay. Yeah, that's good. Your assistant is still running. It looks like the system is running good, and it's just keep tracking the location, right?
Yeah, that's
To
right.
the central server. Okay, that's good. Okay, I like your project. I think tracking is a very important topic, especially inspired by the COVID. The only things about usually the negative part about tracking is that how do we balance between the trackability and some of the privacy issue we might be able to handle, and also we might reduce the amount of the centralized, rely on single point of failure. Because the other thing I don't like about central server is that if the central server fail, then essentially the whole system is in trouble. Yeah. Okay.
Well, regarding this problem, I have an idea on this. Like in this case, maybe we can, we don't store like which people have been which place at what time in central server. We only store that which place has that positive people showed up at which time. We don't store the name. We only store the place and the time. And at this case, the client will keep in track of, okay, so client A has been which place at which time. So as when the client is detected positive, it will upload only the place and the time that he or her has been to the central server. So I think this is maybe could issue the issue of privacy. Yeah.
Right. And also you need to worry about how to get the information about who to inform.
Yeah.
Yeah.
As for who to inform is maybe the client can check with central server like case by case, or client could compare the local check information with the check information that marked positive in central server. So the compare is happened in the client, not in the
it's
server.
a client's responsibility.
Yeah,
to do that
right.
every few hours or something like that.
Yeah.
Actually synchronize. Yeah. To actually track some kind of location that's actually has a vulnerability. Yeah. I think that's a good idea. Okay.
Professor, do we need to do the demo for the homework?
2 and 3. You haven't done it last week, right? Okay, so let me wait for a few hours because I'm actually trying to coordinate with the TA. I want him to do that as soon as possible, maybe later today or tomorrow. If he cannot done that, then I will probably just do it myself. Okay.
But when do we need to arrange or
I
sign
will
up some time?
probably another doodle will be sent out.
Okay, cool. Okay.
Thank you.
Okay,
All
thank
right.
you.
So I'm going to terminate this and then upload the video. Okay. Thank you.